So today we are going to learn about the revenue function. So revenue function, the formula to find the revenue function is P into X. P is the price per unit and X is the output, number of units produced or number of units you sold or whatever it is. So X is the number of units and P is the price per unit. When you multiply the number of units into the price per unit, suppose you just got 100 pen, the price for one pen is 5 rupees. So revenue is 5 into 100. So number of units sold. Okay, this is number of units you sell. So number of units, X is the output, number of units sold, and P is the price per unit, and the revenue formula is P into X. Now we have to find the average revenue. Whenever the word average comes, divide by X. So whenever average comes, divide by X. So average revenue is revenue by X. So that means PX by X. Okay. That is the average revenue. Marginal revenue means derivate the function dr by dx. dr by dx. Marginal revenue is if you sell one extra unit, what will be the revenue? That is called the marginal revenue. Okay, one additional unit if you sell. Suppose 100 units, the revenue is 20 rupees. You are selling one additional unit, 101. Okay, for 100 it is suppose 30 rupees. Okay, now if you sell one additional unit and the income that you are getting is 35. This 35 minus 30 is called as the marginal revenue. So how do you find the marginal revenue? You differentiate the function. Then marginal average revenue. So you take the average revenue and differentiate. Profit. Profit is revenue minus cost, that you always know. Selling price minus cost price. So that is the revenue. Now profit is maximum. This concept you should know. When the marginal revenue is equal to the marginal cost. So the next concept that you are going to learn is very important concept again. Elasticity. This is a graph of the demand function. Now when the price of a commodity increases, what happens to demand? The demand will decrease. See, suppose the price is only 10 rupees. Suppose you take onion, the price is 10 for 1 kg. The demand will be very high, isn't it? Maybe 100 units or 10,000 units or 100,000 units will be the demand. If the price is, suppose it is increased to 25 rupees, what happens to demand? It will decrease. Demand is on the y-axis, it will decrease. When the price is suppose 50 rupees, the demand will still decrease. So the demand is decreasing as the price increases. As the price increases, the demand decreases. So this is a decreasing curve. Now what is elasticity? Elasticity is, suppose if the onion, for example you take the case of onion, if the price is very less, suppose sometimes the price will be very less, 5 rupees something for 1 kg, the demand will be very, very high. Usually only 100 people will buy, but that day because the cost is very less, the price is very less, instead of 100, maybe 1000 people will buy that day, right? If the price is, suppose if it is 2 rupees, what happens? 1000 will become 10,000. So this response, see, this is the measure of this response, how it is varying. 1000 it has become 10,000. So this measure is called as elasticity. It is a measure of response as the price increases. That is called as the elasticity. Now there is something called elasticity of demand and also elasticity of supply. So what is price elasticity of demand? It tells you how much is the response. The measures the degree of responsiveness of the quantity demanded to the change in price. As the price changes, what is the response from the public? So that is called as the elasticity of demand. Now elasticity of demand, there is a formula. Elasticity is denoted by a Greek alphabet. This is eta. So eta is x by y into dy by dx. This is the formula to find elasticity. Now, elasticity of demand minus p by x dx by dp. Demand graph, I told you, the slope will be always negative. It's an obtuse angle. The angle is obtuse. So for the demand curve, if you draw a tangent at a point and you find the slope will be negative because this angle will be always obtuse angle. So slope, you know, it is nothing but tan theta, or it is nothing but dy by dx. Okay, so this tan theta is always negative because this angle, you know, tan one, if it is an obtuse angle, it will be negative. Tan of an obtuse angle will be negative, isn't it? So this will be always negative. So slope is also denoted by dy by dx. So this is always negative. This will always be negative. So just to avoid that, you put a minus sign. So there is one minus here and one minus here. It will give you positive answer. So elasticity of demand, the formula is eta d. Elasticity of supply, the formula is eta s. This is a Greek alphabet, eta s. There is no minus here. Just p by x dx by dp. Supply graph will be, the slope will be always positive. As the price increases, the supply by the producer, this is supply graph is from the producer's side. So when the price increases, the supply, for example, you take the onion itself. When the price is increasing, what will happen? The supply will be more. Why? Because the producer will get more profit. So if the price is very less, he won't supply more. If the price is very high, okay, if suppose the price is some 10 to 50 rupees, the supply will be very high. It will be some 100 or 1000 kg something he will supply. If the price is very less, he will not supply that much because he will not get the profit. So supply graph will be like this. Suppose it is 10, the supply will be only 50 something like that. It's okay, somewhere here. If the price is 25, then supply will be more. If the price is 50, it is still more. If the price is 100, the supply will be more. So you can see the graph is increasing. So when you draw the tangent at any point, the angle will be always acute. So the slope will be always positive. Acute angle, if theta is acute, tan theta will be always positive. So tan theta is positive. That means dy by dx is always positive. So here this will be always positive because it is a supply. So you should know elasticity of supply formula, elasticity of demand, then the relation between elasticity of demand, average revenue and marginal revenue. Elasticity of demand is also equal to AR means average revenue divided by average revenue minus marginal revenue.